This video is about graphing a cosine function. Similar to the sine function, we're going to start with the unit circle. Okay, so when we're looking here at our unit circle, let's go ahead and get these points labeled. This is 1, 0. And up here we would then have 0, 1. Over here, negative 1, 0. Finally, here we go. It's going to be 0, negative 1. You're going to have to know this unit circle, so I would encourage you to go ahead and practice writing it out. Once again, let's look here at this is about our pi over 4, or about 45 degrees. All right, and at that point, we are at the square root of 2 over 2, square root of 2 over 2. Over here, let's go ahead and grab this one here, and this is about 3 pi over 4. All right, and this one's going to be what? Now let's look at the x-axis. All right, so what's it going to be over here? This is then going to be a negative square root of 2 over 2 and positive square root of 2 over 2. All right, down here, which would be about our 5 pi over 4. Both of these are going to be negative now, so this will be negative square root of 2 over 2 and negative square root of 2 over 2. All right, so using these basic points, let's go ahead and let's do up a t-chart so we can then graph this and see what our cosine is going to look like. So on the first, we're going to put this as our theta. And then here, we're doing a cosine this time, so this is going to be cosine of theta. Now, if you remember, what do we know about the unit circle? We know on the unit circle that we can read the cosine of theta right off the unit circle, and it then just equals x. So when we're at 0 degrees, we are sitting on the x-axis when we're here at 0 degrees. So the cosine of theta is then going to be 1, and that is because of this 1 here. At 45 degrees, now remember that's an angle we're measuring from the x-axis. That's running about there. So at pi over 4, this is going to then be square root of 2 over 2. I'm pulling the x-axis values, or x-axis, x-coordinate values. At pi over 2, all right, now what's happening to our unit circle? It is on the y-axis, so then it's going to be 0. At 3 pi over 4, all right, now we're over in here, so it's going to be a negative square root of 2 over 2. Remember, everything's positive in the first quadrant, but only sine is positive in that second quadrant, so it's logical our cosine would be negative in that quadrant. I need to give myself some more space. There we go. Much better. Okay, so our next point is going to be at pi, and we're sitting on that x-axis again, so we're at negative 1. Then at 5 pi over 4, we're going to be again at the negative square root of 2 over 2. At 3 pi over 2, we're going to then be at 0. And finally, when we head back around that circle and we get back to 2 pi, we're going to be at 1. There is another point in here. It's going to be 7 pi over 4, and it's going to be that positive square root of 2 over 2. Let's just take a peek at this real quick. Remember, we're going to graph this as an x here and our y here. We're going to start off on the cosine. We're going to start here at a max. We're then going to decrease, and the 0 is then going to be our intercept. At negative 1, that's going to become a min. 0, we're back to an intercept. and then at 2 pi we're at a max. All right, notice this is very similar if you've seen the sine video to the way sine works. It goes in the same type of order, except a sine curve starts with an intercept, and we'll look at that in just a moment. But now that we've got our chart, let's go ahead and do our graph. All right, so here are the points from our chart. And what happens on the cosine? Well, I'm looking at my cosine y-axis. Remember, this is going to be our x-axis here, and this is going to be the y-axis there. And I'm looking at these, and I'm seeing that basically I'm moving between -1 and 1. So let's label the y-axis accordingly. This is going to be 1, and down here we're going to then have our -1. Okay, on the x-axis we need to put our angle, so let's go ahead and do that. We'll make this about pi/4, and roughly here pi/2. This will then be 3 pi/4. Here we will have pi. Okay, so roughly here we're going to have that 5 pi/4. And then we're here at 3 pi/2. All right, we're missing one off of our chart here. We're going to have a 7 pi/4 hanging out about here. And then we will have over here, this will be 2 pi. All right, so when we're at 0, we're now going to be up here at 1. Let's go ahead and change colors for this. Let's grab a nice purple. There we go. We're going to be up here at 1. Notice, what is pi/4? When I look at my chart over here, pi/4 is the square root of 2/2, and that's roughly about 0.7. That just gives us an idea of where we need to be on our graph. So we're going to be here at 0.7. The pi/2 is then going to be an intercept at 0. 3 pi/4. Now, once again, this is going to be -0.7. So that's going to put me down roughly here. Pi is going to be at -1. 5 pi/4, we're back here. 3 pi/2 is an intercept. At this point here, 7 pi/4 is going to be another square root of 2/2, and then finally we're going to stop at 2 pi. So let's go ahead and sketch this guy in. And I think we can do better than that. Try it one more time. Alright, this is becoming highly amusing. Much better. Alright, so this gives us a rough idea of what that cosine is going to look like. Let's start talking about the domain. When we think about domain, we used to think about x values. We're going to look at theta now. Are there any theta values that cannot happen? And the answer is no. They're all good. Okay, we don't have any asymptotes, we don't have any issues, so it's going to be all real numbers. What about range? Right? Where's our min? Our min is at -1, and our max is at 1, so that's then going to be our range. Let's do a quick comparison between these two. On this graph here, the blue is your cosine curve, and the red is the sine curve. Alright, so let's just examine what's going on. Hopefully you've already seen the sine video. If not, go make sure you watch it. The cosine, we're starting here at a max, but the sine, we're starting at an intercept. So we get this offsetting occurring. What's interesting is notice this point here. Can you take a minute and guess what angle that is happening at? That's actually happening at pi over 4, isn't it? Because at pi over 4, both the sine and the cosine is a square root of 2 over 2. Now remember, when we look at what we're writing out, when we're dealing with these graphs, and we did the real basic ones, what's going on? We're going to have y equals amplitude cosine of bx plus c, and then we're going to have or y equals amplitude sine of bx plus c. Let's take a minute and talk about this a out front, amplitude, okay? Let's talk about that a there. The way we measure the amplitude is we're going to measure it from here to here. It's an absolute value number. It's always going to be positive, and that's going to provide us with the amplitude. The other key that we need to know is then the period. The period, and we'll go ahead and run this off the cosine curve, is then going to be where it starts repeating itself. So our period is going to run on this one from here to here. All right, and what does that give us? That gives us our period. And what does that equal? The period is then equal to 2 pi divided by b, where b is this b here. So it's the number in front of the x. C is going to provide our horizontal shifting and what's occurring with that. Let's go ahead and take a peek, and here is a demonstration of this. Now, notice what this one is set at. There we go. This one has an amplitude right now of 4. That's that a value, and this is a cosine curve. And notice as I increase these numbers, 7 and 8, how it stretches. You get a vertical stretching occurring. B, we said B affected the period, so B affects when it starts over again. So if we get a larger B value, you'll notice that it starts compressing, or we're going to get a smaller period occurring. And remember, the period was 2 pi over b, so it is an inverse relationship. Let's go ahead and move us back to here so that it's easier to see what's going on here with the c value. The c was our vertical. Okay, so c was our horizontal, sorry, not vertical, but our horizontal shifting, and as you see, as I'm increasing this, I'm moving the graph around. And that concludes the discussion of a basic sine curve. We will then start translating, a basic cosine curve. We will then start translating these functions.